Okay, PreCalc, it is time for Chapter 4. Taking a break from all that algebra, the stuff we did in the last 4 chapters. I guess it's 4 chapters, isn't it? And now we're going to start some trigonometry, okay? So if you ever take, if somebody says, well, in college there's no such thing as PreCalc. Well, usually in college you have like college algebra, and then you take trigonometry. They're 2 separate courses, or some high schools do it the same way. We just take PreCalc, which blends them both in there. So will we see features from the first 4 chapters in this chapter? Possibly, but not so much. This is really taking a step back. Trigonometry, yes, we learned SOHCAHTOA back in geometry. This is a completely different beast, okay? And yeah, I might have just called that a beast because it can be tricky. But the more you just stay on top of it to begin with, you're going to be okay. All right. My notes look a little different than normal. It should give you the information you need for your homework. There's a lot in Chapter 4, and you'll notice right away that this set of notes is only 2 pages. That doesn't mean there's not a lot crammed in these 2 pages, and you'll notice right away the next section, I do some separate notes before we get into section 4.2. So a lot of background knowledge, a lot of things that I really wish I was standing in front of you to teach, but we will take it this way and we'll do our best. And it's really important that you maybe rewatch these videos when needed and that you communicate with me if something isn't making sense, okay? All right, so let's talk about angles and radian measure today. Okay, we've worked in degrees with angles for years. The degree measure of an angle is the number of degrees in the intercepted arc of a circle centered at the vertex. Okay, think back to geometry. If I start here at this angle and it's created by here to, let's take this one right here maybe, do you remember that the central angle is equal to its intercepted arc? That's what it's saying, okay? So the degree is the number of degrees in the arc because it's the same thing as the center right here. That's what that's saying, okay? So in this particular one, I'm going to tell you is 45 degrees. So if this is 45 degrees, the arc is 45 degrees. That's geometry coming back in there. Okay, some things we want to talk about. By the way, we're going to deal with them. We're going to deal more with the angles inside the circle, the central angle, not necessarily the arc itself. But you'll see that vocab come in about the intercepted arc. As long as we're talking central angles, they're the same measure. Okay, the degree measure is positive if the rotation is counterclockwise and negative if it is clockwise. We need to make sure that you are comfortable in the unit circle, which is our next thing. We are going to talk about this, that I want to make this kind of clear here. The starting line always is this line right here, okay? This line right here is always the starting line. We always start from the x-axis between the first and the 4th quadrant. That's always our starting line, okay? If we happen to go to counterclockwise, so if we go in this direction, our degrees are going to be positive, okay? Positive degrees. So this was 45 degrees. It's positive, okay? If we go clockwise this way, our degrees will be negative. So the negative and positive is a directional thing, similar to what you see in physics with your velocity. Positive velocity means you're going up, and negative velocity means you're going down. Okay, the same idea here. Positive degrees are going counterclockwise around the circle, and negative are going clockwise around the circle. So important that we understand that, and we understand those negatives and positives. When needed, you give the sign in front of it. There'll be times I'll tell you give a positive answer, or there'll be times where your answer should be between certain bounds, and you have to make sure they are positive or negative depending on what those bounds are, okay? As we get to that, I'll remind you, but I just want to tell you that there's no like, oh, always give the positive answer. No, the negative is telling us some direction, and we need to do that. Okay, the unit circle that we see here is a circle centered at the origin of the coordinate plane with a radius of 1. So important to know this. So if I put this on the coordinate plane, I'm at 0, 0 in the center of the circle, and the radius here is 1, okay? By the way, you see a lot of lines through the circle. Every one of them then has a radius of 1. That is the meaning of unit, 1 unit circle, okay? So important we know when we're working with the unit circle and when we're working with a circle that's not necessarily has the radius of 1, okay? But when we talk the unit circle, when you see that in your notebook, I gave you like 4 or 5 copies of this, that circle has a radius of 1. Okay, I already talked about how our first and our line here, this red line, is where we go off of. This is called the initial side, okay? It will never change on a unit circle. This is always the initial side. So when we talk about an angle, one of the rays of the angle belong right there on that x-axis, always on that x-axis, okay? And then what we do is we have a terminal side where it ends. Terminal means end, right? And it's the second ray of that. So if I take, and I'm going to switch colors again so you can kind of see this. If I take an angle, I'm going to say it goes right here, okay? So it has to start here. Every angle starts down here on the initial side. The terminal side is where it stops somewhere on the unit circle, okay? So in this case, if I go this direction, this is 120 degrees positive, okay? If I go maybe an angle going this way, right? This would be negative 135 degrees because I'm going counterclockwise, okay? But, and again, it depends here. We'll talk about this, that this same negative 135 is a positive 275, okay? Not 275, sorry. Do my math here. How about, yeah, 215? Maybe that's the better answer. 225. Okay, ignore my ramblings, okay, because obviously I'm not thinking super clearly. Okay, just so you know, this same negative 135 is the same as positive 225, okay? We'll get to that, and so you can do those, okay? So, terminology here. Initial side, always the x-axis. Terminal side, where it ends. Positive goes counterclockwise. Negative goes clockwise, okay? Big ideas that we have to have clear before we can move on in our unit circle. Okay, your brain is good on degree. That's what we're used to. That's what we've done. We need to make a shift, okay? And we're going to make this shift into also radian. When I say shift, though, I don't mean a permanent shift. I mean we need to be able to go in and out between degree and radian measure, okay? So, super important that we can work in radians. And you will realize by the time we finish chapters 4, 5, and 6 here, radians are good. They actually help us, and they're actually sometimes easier to work with than degrees in what we're doing, okay? But radian measures used in the scientific fields, okay? And they result in simpler formulas in trigonometry and calculus. So, radian measure. So very important to know, okay? And I'm kind of jumping ahead a bit, but most radian contains pi, but sometimes it's a decimal as well. So don't always say that if I see pi, it's a radian. If I don't see pi, it has to be degrees. Radians can be a decimal as well. I can't stress enough, if you do not put a degree sign on an angle when it's in degrees, you are telling me it is in radians, okay? If there is a number with nothing marked, it is radians. If you want it to be degrees, you must put a degree sign on it. That's not tough. Tiny little circle up there at the top. Make sure your degree sign is there if it is degrees. And radians can either have pi or just nothing. So if it's unlabeled, it is assumed it is radians, okay? All right, so we have this definition of radians. 1 radian is the measure of the central angle of a circle intercepted in arc equal in length to the radius of the circle. Okay, so the easiest way to tell you, 1 radian, okay, on your unit circle, 1 radian is exactly halfway, okay? There's 1 radian. It's called pi because we do it in pi. So 1 pi is 1 radian. That's saying that on the unit circle, whose radius is 1, if I run my circumference equation, half of the circumference of this circle that has a radius of pi, this arc would have a length of 1 as well. Does that kind of follow? The measure of the central angle that intercepts the arc equal in length. So what this is saying is this measure of this is going to make it so that the radius is equal to the arc. That's what a radian is, 1 full radian. You'll notice when we work with radians, almost all of our radians are going to be fractions, okay? And I did say that, fractions. I don't want decimals. I want fractions when we are dealing with pi. When it's not dealing with pi, decimals are fine. But when pi is used, we want fractions. Okay, so we have one formula here to find the radian of the measure of an angle. Okay, one heads up. We're going to start using a lot of Greek letters, okay? This one happens to be beta. You'll hear me say this. The other popular one you're going to see a lot of times is this theta, okay? It looks like a circle with, or a zero with a horizontal line through it. So just know, don't get scared by these symbols. The big idea is we're going to not use x as much because we start using words like sine, cosine, and tangent, and because those are using our, for lack of a better explanation right now, because they're using our English language, okay, or letters from our English language, S-I-N, C-O-S, T-A-N, the X can sometimes just blend with that word and we might miss it. So sometimes we bring in these Greek letters that have a different look to them and they're not part of our English language. So there's a little separation between the variable, which is the Greek letters, and the English language, which are the letters to form sine, cosine, tangent, or whatever else we use, because we will use more than just those three. Okay, so that's just a side note. I just don't want you to freak about those Greek letters. That's all they are. They're Greek letters. They're going to be our variables many times, okay? So it says to find the radian measure of this angle in standard position, divide the length of the intercepted arc by the radius. So equation there, I'm going to be honest, we don't use it a lot. Don't worry about memorizing it. Just for tonight's homework, use it when needed, okay? My next note over here, radian measure is called a directed length because it is positive or negative depending on the direction of the rotation of the initial side. That is identical to what we did with our plus and minus up above with our degrees. So that is not new. That is just saying once again that if you directed means that we use that negative and positive. So once again, if something's positive, it's going counterclockwise. If it is negative, it's going clockwise. That's all that's saying about the directed length, that the positive and negative is giving a direction. Okay, we talked about radians containing pi, but not always, and let's work through a problem here. So our first example, a central angle, theta, just a Greek letter, don't stress over it, in a circle of radius 14 feet, intercepts an arc of length 40 feet. What is the radian measure? Okay, so theta, which is our angle here, is going to be, we're going to use the length of the intercepted arc on top. So our intercepted arc's length is 40 feet. We're going to divide by the radius, which is 14 feet. Always good to double check those units, make sure they're the same. If they are, they basically cancel each other. I can reduce that maybe to 20 over 7 when I divide by 2. So either 20 over 7 radians, or you can hit that on the calculator. It's not, it's about 2.9, okay? So either one of those is an acceptable answer for the radian measure. Okay, I need to give you a quick visual here. I did tell you that pi goes halfway around. So a full circle is 2 pi in radians, okay? Talking decimals, just so you know. So pi, we already know, is like 3.14. 2 pi is like 6.28, okay? So just keep in mind when you're talking radians, so 2.9 would be somewhere about in that second quadrant, right? So always keep in mind you can kind of get that visualization if you keep in mind what the unit circle is. We know a unit circle is 360 degrees, but when we switch it to radians, do you kind of know where you're at, okay? And again, we'll do this more on the backside too, but the two circles are not separate. You do not have a degree and you have a radian. They're really the same circle, measured in different units. That's the deal. So keep in mind, a full circle in radians is like 6.28 radians. That's the decimal. As a pi, it's 2 pi. So that's kind of, I just want to kind of throw that out there as giving you an idea of where we're kind of at on this unit circle. Okay, again, another huge thing we have to do, and this you're going to do back and forth all the time. Conversion from degrees to radians or radians to degrees, okay? And we have this conversion factor, and that is simply what it is. It is a conversion factor. There's 180 degrees in pi radians, okay? If you think about our half circle, a half circle was pi. That's 180 degrees, that's pi. If you remember that, that's good. By the way, when you take the SAT, I believe this is on your formula sheet, it will say 180 degrees equals pi radians. All the non-pre-calc students that take SATs, they kind of freak out because they're like, I don't even know what that means. You have the advantage because you're getting introduced to it. They might be able to figure it out if they're just good at using unit conversions, but from here on out, you have the advantage because you're going to get fluent in your radians, okay? All right, so A, we're going to convert 205 degrees to radians. Can I stress again, if we're using pi, do not go to decimals, go to a simplified fraction, okay? So when we do conversions, it's just like we do in any other class. 205 degrees, okay, I'm going to put it over 1. So I really have a unit. Degrees is a unit. If I want to get rid of degrees, I put it on the bottom and put what I want on top. Well, I want to go to radians, so I'm going to put pi on top, and pi is equal to 180 degrees, okay? Keep that in mind. You're trying to cancel degrees. Put degrees on the bottom, put pi opposite, okay? So my degrees cancel each other because, yes, those were units. I get 205 pi over 180. Is there any simplifying I can do? A number that goes into 205 and 108, or 180, sorry. Divide by 5. So I get like 41 on top and 36 on the bottom. All right, so I get 41 pi on top, 36 on the bottom. I'm good. That's my radian answer, okay? You don't have to write the word radians beside it. If there's nothing written, it's assumed it's radians, okay? So let's look at the next one. I have pi. There's no units written, so I'm assuming that is radians. So I have negative 3 pi over 2, and I want to switch it to degrees, okay? I see my pi on top, which means I want my pi on bottom to cancel, and that's equal to 180. So there's my unit conversion, right? And that's what I'm going with. Okay, what's nice is the pi's cancel. I can take 2 divided by 2 and get 1, 180 divided by 2 and get 90. Across the top, negative 3 times 90 is negative 270 degrees. I have to put the degrees because if there is not a degree mark, it is assumed it's radians. So make sure that degree mark is there. All right, last one on these examples. Convert 10.3 to degrees. There's no unit given. We assume it's radians, okay? So we assume it's radians. That means I want pi on the bottom and 180 degrees on top. Whatever I'm trying to go to should really be on top, okay? This is not a good problem at all as far as simplifying. There's nothing pretty about it. This is a straight up calculator problem. I'm going to take 10.3. I'm going to multiply times 180. And then I'm going to divide by pi. I'm going to use the pi button on my calculator. I get about 590, oops, don't know what happened there. 590 point, I don't know, I'm going to go 15 degrees, okay? I'll tell you on a test or quiz what to round to if it doesn't come out equal. Okay, are we comfortable with the conversion factor? It doesn't matter that we only convert between the two, radians to degrees. If you're in degrees, make sure that degree symbol's there because everything else is assumed to be radians. All right, let's go to the back. Let's talk about these. Okay, I need to stress this one more time. I know I told you that the degree and radian circles are not separate, and now I separated them. I'm only separating them so that we don't get overwhelmed by the numbers on these, okay? But truly, it is the same circle. It just depends what unit you want to work with. Okay, so let's talk degrees of a circle, okay? I'm going to start real basic. You might have noticed every time I give you this circle, I have these lines inside the circle. Always the same 3 lines in each quadrant, okay? That's important because those are our target points in our unit circle that we're going to work with. So as we work through these, we need to know the degree for each of those lines. We need to know the radian for each of those lines. We need to know ordered pairs for each of those lines. There's a lot of things we're going to learn about them. So follow me here. This is the starting point of understanding what are the important values on your unit circle. Okay, we're going to start in degrees. A circle starts at 0 degrees, and we always start down here, of course, on our initial side. Okay, we start at 0 degrees. If I go fully around that circle, I'm up to 360 degrees. That is the only point on our unit circle that gets 2 degrees and 2 measurements, okay, is the 0 and 360. We start at 0, we end at 360. That's one full circle, okay? So what's halfway around the circle? Well, most of you know that. That's 180 degrees, okay? My guess is you have no trouble with straight up. Straight up, if I start at 0 and I'm going counterclockwise, straight up is 90 degrees. I get to 180, I add 90 more to 180, I'm down here at 270, okay? Those are probably the easy 4 or 5, because of that 360 there, measurements that are easy to find. I like to start with them. It keeps me focused. I'm in between there. Now, everything between 0 and 90 needs to be a number between 0 and 90. That makes sense, okay? All right, so let's talk now. I can't stress enough that, let me do this black one. This x-axis is the key that everything comes off of. Everything comes off of the x-axis, everything, okay? So when we talk about numbers here, we are talking about how far away they are from the x-axis, okay? So just so you know, my first line here is 30 degrees up from the x-axis, okay? Across into the second quadrant, that first line from the x-axis is still 30 degrees away. So if I take 180 and I subtract 30, I'm at 150, because everything here, this is 30 degrees off on either direction. It's also 30 degrees off down in the third quadrant. So if I take 180 and I add 30, I'm at 210. See, this is what I was trying to do in my head earlier, and I was not very successful. Okay, so in the fourth quadrant, we're still 30 degrees off. So that's like 360 minus 30, which is going to get me 330, okay? So each of those that are exactly the first line off the x-axis, whether above or below the x-axis, are exactly 30 degrees off from the prior measurement, okay? Does that kind of follow where I'm getting those and how I got those, okay? Oh, I'm trying to write neatly and it's not helping. It's not working very well. Okay, so each of those lines is exactly 30 degrees off, okay? Let me go to the next set of lines. The middle lines, they are exactly in the middle of each one. And halfway between 0 and 90 is always 45. So the middle line is 45 degrees. And again, everything off the x-axis, all of those middle lines are exactly 45 off. So if I do 0 plus 45, I get 45. If I do 180 minus 45, I get 135. Okay? If I come off this x-axis down here, if I do 180 plus 45, this is the number I couldn't get earlier, is 225. If I do 360 minus 45, I get 315. All of those are 45 away. Now, some of you might say, you know what? I think it's easier to go 0 plus 45. I add 45, I get 90. I add 45, I get 130. I add 45, I get 180. I add 45, I get 225. I add 45, I get 270. I add 45, I get 315. I add 45, and I get 360. That's exactly the same thing too. So more than one way to see these values, but I really need you to understand, if I get stuck, what am I thinking of? Where am I going from here? Okay? All right, we have one more set, I'm going to call it, of lines, okay? I need a new color. So again, off the x-axis, this angle right here is 60 degrees off, okay? So everything is 60 degrees off the x-axis. So as I come to this one, 180 minus 60 takes me back to 120, okay? 180 plus 60 takes me to 240. 360 minus 60 takes me to 300, okay? So if you go off the x-axis, everything is those reference angles. And I'm going to use that word a lot, reference angles. My first quadrant is, those are my reference angles, okay? That 30, 45, 60, and 90. So if you can remember the numbers in the first quadrant, 0, 30, 45, 60, 90, you're going to be able to replicate those same values into the other three quadrants, okay? Using the rule that how far away are you from the x-axis? Are there other ways to find it? Yes, but I'm going to stress to you, if you always keep in mind off the x-axis, it will help you with future values that we need to find, okay? All right, how do we feel in degrees? I'm going to be honest, it seems like I overdid it, but that information is really valuable so you can build your unit circle from there, okay? I'm going to come over and do the radians, and just know you can now take everything on the degree, you can use your radian conversion of pi over 180 with every one of these numbers, and you can find their matching line on the next circle. That's fine, you can do that. It will take you a long time. You will spend hours just working on your unit circle if that's the method you want to do. So what I'm going to stress is we need to learn, how do I fill in a unit circle with radians, okay? So again, I'm going to kind of show you my method. You have to find what's comfortable for you so that you can do it quickly and correctly, okay? There's not room for errors on these unit circles. Okay, once again, I'm starting at 0. I don't put a degree mark because there's no degree. Anything unlabeled is assumed to be radians. Okay, 1/2 is pi, the full circle is 2 pi. Okay, it's important that we understand that. And remember, in the back of your mind, you're saying if I turn those to decimals, half the circle is 3.14, the full circle is 6.28. Unlabeled, without a degree mark, those are radians. Okay, halfway between 0 and pi is pi over 2. Okay, and I do not want to see 0.5 pi ever. I want to see a fraction. Between pi and 2 pi is 3 pi over 2. Okay, because it's pi plus half a pi, so it's 3 pi over 2. I don't want to see 1.5 pi. I want to see 3 pi over 2. Okay, those are our 4 kind of anchor marks. Okay, I'm going to go next to, I know I didn't do it this order before, I'm going to go next to the middle lines. Okay, so halfway between 0 and pi over 2 is pi over 4. Okay, which, if you use your unit of conversion, goes right to 45 degrees. Okay, I'm going to just start, and I'm going to be honest, I like to fill in my radians going around the circle. I started at 0. I get pi over 4. That's 1 pi over 4. 2 pi over 4 simplifies to pi over 2. It's already on my circle. I add another pi over 4, and I'm up to 3 pi over 4. Okay, 4 pi over 4 simplifies to pi. My next middle one is 5 pi over 4. Notice I'm just adding a pi over 4 every time. 6 pi over 4 gets me over here to my 3 pi over 2 because they simplify to the same number. I add another pi over 4, I'm up to 7 pi over 4. And if you think about it, if I add one more pi over 4, I'm at 8 pi over 4, which is the same as 2 pi. So I can effectively go around my circle just adding pi over 4 every quarter mark, okay? And I get my values for my unit circle. When necessary, I would need to simplify them, which I already had them simplified because I started with the halves, okay? So I have my middle lines. Now let's go to our, the 30 degree, okay? The 30 degree is pi over 6. Okay, so from 0 to the first line is pi over 6. If I add another pi over 6, I'm at 2 pi over 6, which simplifies to pi over 3. Notice I'm filling in the 60s at the same time. Okay, if I add 3 pi over 6, that's the same as pi over 2, which I already have from before. It simplifies down. Now at 3 pi over 6, I add another pi over 6. I'm at 4 pi over 6, which simplifies to 2 pi over 3. Add another pi over 6 to 4 pi over 6, I'm at 5 pi over 6, which doesn't simplify. 6 pi over 6 is the same thing as pi, so I'm to that line there. I add another pi over 6, I'm up to 7 pi over 6. That's my next line. Notice we're skipping those pi over 4s because they don't correlate, right? And I add another, I'm at 8 pi over 6, which simplifies to 4 pi over 3. I add another, I'm at 9 pi over 6, which simplifies down to my 3 pi over 2. I add another, it's 10 pi over 6, because I added another pi over 6, which simplifies down to 5 pi over 3. And finally, 10 pi over 6, I add one more pi over 6, and I'm at 11 pi over 6, which doesn't simplify. If I add one more, I'm at 12 pi over 6, which is the same as 2 pi, and I'm around my circle. Increments, they're actually equal increments. That's what we're doing. And if you think of your fractions of just adding one more of that pi over 6 each time, we land on those lines, okay? So notice I don't have to go back through and do my 60s because I caught those using my 30s, okay? So they're really part of the same family on there as far as the fractions go, okay? What you see right now for your radian measure, the close circle, obviously the ones outside, those were my numbers I ended up simplifying so you could see that, but what's on that circle, those are the values you need to give. I don't ever want to see decimals with the pi. They need to be fractions with the pi. That's how we're going to relate in radians, okay? Remember, these two circles really can be superimposed on top of each other because each line represents a value for a degree and a value for a radian, okay? I know for 2 pages, these notes are taking a lot, but I'm really trying to get you a really solid base on this unit circle, okay? Okay, this next note we'll come back to, and I'm going to be honest, I need to work harder to always call them coterminal angles because I don't think I always do. So possibly my own use of the vocabulary is going to throw us off a little bit here, but keep in mind the idea at least. Okay, coterminal angles are angles in standard positions that have the same initial side, the same terminal side, but possibly different rotations, okay? What you see on the unit circle right now says I go from 0 to 360 degrees, or I go from 0 to 2 pi. Obviously, there's a lot of other numbers, however. So here's what's true, though, about the unit circle. This is the one and only unit circle. I don't have different unit circles. I can't make a second circle that goes to 720 degrees. It doesn't happen. What happens is we keep rotating on this same circle over and over, okay? So if I'm anything bigger than 360, that means I went 360 plus some more, and wherever we land is the coterminal angle is bigger than 360, but it relates back to an angle on my unit circle, okay? So what we find is the values on the unit circle are set. They're only between 0 and 360 or 0 and 2 pi. They can't be any other values, okay? But we can use this same unit circle for anything larger than 360, or should I say even smaller than negative 360, or larger than 2 pi, or smaller than negative 2 pi if we go the opposite way, but we relate them all back to these unit circles, okay? So what's important is we need to think about the what is on the unit circle that we want to go back to, okay? So let's do a couple examples so you kind of see what I'm saying here. I don't want to move my unit circle too much, but okay. It says find a positive angle, and it's important we know which one we're stopping at, less than 360 or 2 pi for 415 degrees. So 415 degrees is definitely more than the circle, okay? So what we want to do is simply subtract 360 from it. We subtract 360 and we're at 55 degrees, okay? We have a positive angle, it's less than 360, and that's my coterminal angle. Okay, I need to make sure we understand. Is 55 degrees on my unit circle? Yes, it is. Is it a value we're going to memorize? No. But don't think that just because it's not an angle up there on my unit circle that I labeled, that it's not on the unit circle. It's definitely on the unit circle. It's somewhere between 45 and 60. When we do anything that's on my unit circle that I took the time to label right now today, those are values we're going to find exact values for over and over and over. All the rest of them, we're going to need a calculator, a computer, something like that to find the values, but they're still on my unit circle, okay? So keep that in mind. It's not limited to the ones we have up there in labeled. It's limited between 0 and 360. Some of them we can find exact. The ones you see up there, we're going to work in exact values. The rest can have decimals, okay? All right, let's look at the next example. And it says find the positive angle less than 360 or 2 pi for negative 23 pi over 5, okay? Anytime we're dealing with positive, you want to add your circle to it. And that's how I'm going to say it, add the circle to it, okay? So I'm going to start with negative 23 pi over 5, and I'm going to add 2 pi to it since we're dealing with radians, okay? So quick note here, 2 pi. This is fractions. We need a common denominator, right? So if I make this 5 on the bottom, I have to make this 10 pi on the top. So I'm going to say 10 pi over 5 instead. It's just going to be easier for my brain. Okay, I take negative 23 pi over 5. I add 10 pi, which is one circle. I get negative 13 pi over 5. Am I in a positive angle yet? No. So guess what? We're going to do it again. Negative 13 pi over 5. I'm going to add another 10 pi over 5, which is equivalent to our 2 pi. I'm at negative 3 over 5. Am I in a positive angle yet? No. So add 10 pi over 5 again. You always have to add the full circle. When I add again, I'm up to 7 pi over 5, okay? Now I'm positive, now I'm in my unit circle. okay? Quick check, because again, our brains need this mental thought. 7 pi over 5, 7 over 5. Is that number between 0 and 2? It is, so it's between 0 and 2 pi, okay? So that's when I know that I'm on my unit circle. Once again, I don't see 7 pi over 5 up there in the radian circle, but it's somewhere in between my angles, right? So it's probably in that third quadrant over there somewhere, right? So it's up there. If we needed to find something, I need a calculator or a computer to do it, but it is a value within the unit circle, okay? All right, one more thing here. Arc length is the radius times the theta, whatever angle we have, okay? But what I need to make sure you know is, as if we use this formula, it needs to be in radians, it cannot be in degrees, and it can't be negative. It needs to be a positive radians to use this formula, okay? So it says, find the length of the arc on a circle of radius 9 yards, intercepted by a central angle of 315. Okay, so to find this, it's a pretty simple equation. I need the radius times the radian, but I'm not in radian yet. So let's go ahead and switch to radian, okay? So I have 315 degrees. Remember, the switch to radian means put degree on the bottom, pi on top, so I put my 180 down here. I'd like to leave it as exact as possible, which means keep that fraction, don't do a decimal. What can go into 315 and 180? 5? Okay, 5 goes in 63 times here, 5 goes in 36 times here. Can I reduce again? Maybe by 9? So I get 4 by 9, 7. Okay, I think I get 7 pi over 4, and I don't believe that can reduce again. So there's my radian, so I can use this formula. So my arc length is going to equal my radius, which they gave me was 9 yards, times my non-negative radian measure. It's not negative. I've got it back into radians, so I do 7 pi over 4. And I'm just going to go straight across. Okay, so I get 63 pi over 4 yards. There's my exact arc length. I mean, if I needed to, I can put it into a decimal, right? But that's to use my formula. Okay. Hope you're feeling good on these so far. We're taking a break because on 4.2, we need to add more to our unit circle. We're not done with our unit circle yet. But hopefully today you feel good between the degrees and the radian and what a unit circle is in general, okay? Practice, page 472 to 474, I would recommend the 3s, 3 through 87, 41 through 55 all, 77 through 82 all. Key thing is practice. Okay, you choose. Is it odds you're using? Are you using Slater so you're checking some of the evens? Please, please, please practice, because none of this is off the top of your head, probably already knew it. You need to do some practice. Let me know if you have questions.